All right, so today is November the 19th, 2020, and we're starting partial derivatives. So under that, I have the notation for partial derivatives. And this said, if z is a function of x and y, then the first partial derivative with respect to x is represented by delta, I think that's delta z by delta x, which is the same as saying delta f by delta, or del f by del x, del f by del x, and that is the same as saying, so we're looking at different notation for representing the first partial derivative with respect to x. So if you see f underscore x of x, y, this is asking for the first partial derivative. Or if you see del x of f of x, the function xy, this is asking you for the first partial derivative of f of x with respect to x. All right, so we're looking at the notation. If you see del z, del y, del f, del y, or y, or f subscript y of x and y, or del y of f of xy, that is the notation for the first partial derivative with respect to x and the first partial derivative with respect to y respectively. Here it is. To find del f by del x, we differentiate the function with respect to x while keeping y constant. And to find del f by del y, we differentiate the function with respect to y while keeping x constant. All right, so I'm going to show you what that means. I'm going to do example 51, then I'm going to ask you to do example 52. Example 51 says, find the partial derivative del f by del x and del f by del y of the function f of y, f of x and xy is equal to x cubed plus 4x squared y cubed minus y to the fourth power. All right, so I have f of x, or f of xy is equal to x cubed plus 4x squared y cubed minus y 4. Now, if we're asked to find del f by del x, essentially what we're being asked to do is to differentiate the right-hand side with respect to x, and at the same time, you're going to treat y as if it is a constant. If you differentiate partially with respect to x, you're going to keep y, or you're going to treat y as if it is a constant. So when you look at y is like 3, or y is like 2, or y is like 1, you're treating y as if y is a constant. So let's differentiate with respect to x. And differentiate x cubed with respect to x, you're going to get 3x squared. Now, if I differentiate 4x squared y cubed, treating y as a constant, if I differentiate that with respect to x, I'm going to get 8x y cubed. I'm going to treat the y cubed as if it is a constant, so I'm going to get 8x y cubed. All right. Now, if I differentiate y to the fourth power partially with respect to x, I'm going to get 0. If I differentiate y to the fourth power partially with respect to x, I'm going to get 0. Because when you differentiate partially with respect to x, y is a constant. And when you differentiate a constant with respect to x, you're going to get 0. Now the same function, f of x, y, is equal to x cubed plus 4x squared y cubed minus y to the 4th power. Now I'm going to differentiate the function partially with respect to y. I'm going to differentiate the function partially with respect to y. Now, if I differentiate a function partially with respect to y, whenever I see x in the function, I'm going to treat it as a constant. Whenever I see x in the function, I'm going to treat it as if it is a constant. All right, so if I differentiate x cubed partially with respect to y, I'm going to get 0. Because if I differentiate partially with respect to y, wherever I see x, I must treat it as if it is a constant. And when you differentiate a constant, you're going to get 0. If I differentiate 4x y squared partially with respect to y, I'm going to end up with 4x squared y. If I differentiate y to the 4th power partially with respect to y, I'm going to get 3y cubed. All right. So what, yes, give me a second. Let me just finish it up. So what I've just done is I've just partially differentiate the function f with respect to x, and partially differentiate the function f with respect to y. I'm pausing so that you can ask your questions. All right, so
there you have 3 instead of 4.
I'm gonna fix here. I don't know what happened to me. Temporary insanity, maybe. All right,
It's
so
fine.
if I differentiate x cubed partially with respect to y, I get 0. If I differentiate 4x squared y squared partially with respect to y, 2 times 4 is 8. X squared y minus, if I differentiate y to the 4th power partially with respect to y, I'm going to get 4y cubed. All right, thank you guys for the correction. Thank you for ensuring that you're paying attention. So please try example 52. All right, so example 52 is asking us to differentiate the function z partially with respect to x. So let's write the function z. This is x squared plus y, the cosine of 2x squared y. All right, and we're going to partially differentiate this with respect to x. If you partially differentiate a function with respect to x, you must treat y as a constant. When you partially differentiate with respect to x, you must treat y as a constant. So del z, del x. This is a product differentiation. So product differentiation means that I'm going to apply the product rule. So the product rule says leave the differentiate the first, leave the second. No, sorry. Leave the first, differentiate the second. Let me just write it. At momentary lapse. Y is equal to uv. So dy by dx is equal to u dv by dx plus v du by dx. All right, good. So we're going to leave the first. The first is x squared plus y. Leave the first, differentiate the second. When I differentiate cos, I'm going to get minus sign. So this is times minus sine 2x squared y. Then I have to multiply by the differential of the inside function. The inside function is 2x squared y. When I differentiate that, I'm going to get 4xy. So that is leave the first, differentiate the second, plus differentiate the first. If I partially differentiate x squared plus y with respect to x, I'm going to get 2x. I'm going to get 2x. If I partially differentiate x squared plus y with respect to x, I'm going to get 2x. So this is 2x. So differentiate the first, leave the second. The cosine of 2x squared y. So let's tidy it up. We're going to end up with minus 4x y x squared plus y sine 2x squared y plus 2x, the cosine of 2x squared y. So I just partially differentiate with respect to x. Let's partially differentiate the same function with respect to y. So del z by del x, sorry, del y, del x by del y. All right, so this time around, I'm going to treat x as a constant. So I'm going to leave the first because it's still a product differentiation. I'm going to leave the first, which is x squared plus y. Differentiate the second. I'm going to differentiate cos 2x squared y with respect to sorry,
Y.
partially differentiate with respect to y. When you differentiate cos, you still get sine. So it is sine and we have 2x squared y. Then I have to multiply by the differential of the inside function. The inside function is 2x squared y. If I differentiate that partially with respect to y, treating x as a constant, I'm going to get 2x squared. So I just differentiate the first, leave the first, differentiate the second. Now I'm going to differentiate the first. If you partially differentiate x squared plus y with respect to y, you're going to get 1. If you partially differentiate x squared plus y with respect to y, you're going to get 1. Because remember, you're going to treat x as a constant. So it's differentiate the first and leave the second. The second part is cos 2x squared y. And so putting up my answer, I would get minus 2x squared into x squared plus y, and then times the sine of 2x squared y plus the cosine of 2x squared y.